There are many blood groups in the human population, including the ABO blood groups, RH, KIT, Duffy, MNS, Louis, and so forth. But the most important of these are the ABO blood groups and the RH blood groups. Look at this table here, you can see the image of the ABO system of blood groups. I'm sure you're all familiar about the ABO blood groups. So 4 blood groups are possible with this. That is the A blood group, B blood group, AB blood group and the O blood group. It is based on 2 agglutinogens or antigens A and B. So if an individual has the blood group A, you can see that their RBC is provided with agglutinogen A and the plasma will contain agglutinin B. Whereas if a person has the B blood group, their RBCs will possess B agglutinogen while the plasma will have the agglutinin A. So what will happen in blood group AB? You're right, the RBC will possess both A and B agglutinogens while the plasma will be devoid of neither A or B agglutinins. And in persons with the O blood groups, the RBC will possess, yes, neither A nor B agglutinogens while the plasma will have both agglutinin A and agglutinin B. And these agglutinins are of IgM subtype. From this observation, Landsteiner put forward the 2 laws. Landsteiner law 1. If the RBC is having an agglutinogen, the corresponding agglutinin will be absent in plasma. Landsteiner law 2. If the RBC does not possess an agglutinogen, the corresponding agglutinin should be present in the plasma. Let us discuss about the inheritance of our ABO blood groups. Our blood groups are inherited from our parents. The ABO blood group is determined by the A, B or O genes. Of these, A and B are called codominant. That is, if A or B genes are present, these antigens will be expressed on the surface of the RBCs, whereas the O gene is called silent. So there are 3 genes which code for the agglutinogens O, A and B. Now as shown in this diagram here, only one copy of the gene will be contributed from one parent and the antigen will be determined by the allele of genes which is dominant. Now let us take for example blood group A. There are 2 possible genotypes for the blood group A individual, that is OA and AA. So AA will definitely have blood group A, but even if you get one copy of O from one parent, you will still have an A blood group because A is dominant. Similarly for B group, there are 2 possible genotypes, that is OB and BB. For AB blood group, the only possible genotype is AB. Similarly for O group, there is only one possible genotype, that is OO. So in blood group determination, there are other applied aspects. For example, it helps us to give a negative statement in a disputed paternity case. How is it possible? Supposing both parents have A blood group, the child obviously cannot be B, right? Because the possibilities would be AA and OA for each of the parent and the child cannot be B. Similarly, if both the parents have a B blood group, the child cannot be A. So this is how it helps in applied aspects as well.